Okay, in today's video, we're looking at half-lives. Now, you need to be happy with the concept of decays before you watch this video. If you're not, check out the other video in the description below. So far, when we've looked at decays, we have only considered one lonely nucleus decaying all alone. Aww. However, I know if I had a rock of radioactive uranium, there wouldn't just be one nucleus. There would be millions of billions of unstable uranium nuclei in that rock. Sounds very chaotic. So the question is, do they all just decay at once? And when do they decide to decay? Like, is their decision affected by the weather or their mood or, I don't know, their star sign? The answer is no, they don't all decay at the same time. And the time at which they do decay is not affected by any external factors. So we can say that all of our uranium nuclei will decay randomly. And it's not possible to predict when one uranium nucleus is about to decay. Now, that being said, whilst I can't predict when this particular nuclei is going to decay, I can predict how long it will take for a proportion of these uranium nuclei to decay. So it's time to introduce the idea of a half-life. A half-life is a time taken for half of the undecayed nuclei to decay. What? Okay, let's think about this. Imagine you had 32 unstable nuclei. And let's say these nuclei have a half-life of 2 hours. That means that when 2 hours have passed, there will be 16 undecayed nuclei remaining. Now you've got 16 of them left. If you let another 2 hours pass, or another half-life, you will have 8 undecayed nuclei left. Then if you let another 2 hours go by, you will have 4 undecayed nuclei left. Note, in all of those decays, I wasn't able to predict which particular nuclei was going to decay next. Only that after one half-life had passed, half of them would have decayed. You can plot that example that we just did on a graph like this. Here on my y-axis, I have the number of remaining undecayed nuclei, and on my x-axis, I have the time that has passed. Note that you get this exponential curve like this, and the bottom of your curve should never reach 0. Half-lives of different isotopes vary. For example, the half-life of uranium is 4 times 10 to the 9 years. Some isotopes have half-lives that only last fractions of a second. There is a second definition of half-life for your GCSE. It is the time taken for the activity of your source to half. What's activity? Activity is the number of decays per second. Measure it in a unit called Becquerels, where 1 becquerel is 1 decay every second. So after every half-life that passes, the number of decays happening per second halves. Thanks for watching. Please make sure that you download the notes, watertight definitions to learn, and an example half-life graph. If you found that explanation useful, please do like and subscribe. In the next video, we are going to look at some calculations with half-lives and interpreting half-life graphs.